So let's solve a system of three variables, three equations that have infinite solutions. Now, at this point, we have no idea if they're infinite solutions. So we're just going to approach it like any other system that we're solving out of the calculator by doing elimination. So we need to figure out what variable we want to eliminate. And it doesn't matter which one. So now if we look at the question, it says show out x and y with respect to z. So you don't have to do it that way, but if we're going to do it that way, I'm going to not eliminate z. So I'm going to eliminate x or y. So if I call this equation 1, equation 2, or equation 3, since x and y both have like coefficients of 1, it doesn't really matter. You can make the same argument with y. I'm just going to eliminate x. So I'm going to take equation 1 and add it to negative 3 times equation 2. So if I take negative 3 times equation 2, that gives me negative 3x plus 3x, that cancels out. And then negative 3 times y plus 4y is just y. And then negative 3 times z is negative 3z minus 2z is negative 5z. And then negative 3 times 2 is negative 6 plus 6 is 0. All right, then take equation 1 and add it to negative 3 times equation 3. So if you look at the bottom equation, negative 3x plus 3x cancels out. Negative 3 times 2y is negative 6y plus 4y is negative 2y. Negative 3 times negative 4 is 12 plus negative 2z would be 10z. And then negative 3 times 2 is negative 6 plus 6 is 0. All right, so now these are our two new equations with two variables. So if you notice, these are actually the same equations. The bottom equation is just a multiple of the top equation by negative 2. All right, so if you didn't notice that and you went to solve these now by like doubling everything in the top equation and not doing anything to the bottom equation, and doubling it to get opposite coefficients with y, 2y and negative 2y would cancel, but then so would negative 10z and 10z. So we get 0 is equal to 0. All right, so that is an identity. So that's something that's always true. 0 is always equal to 0, not for only certain values of x and y. It's true no matter what. So that tells us that we have infinite solutions. Okay. So once you eliminate variables and you eliminate all of them, like not on purpose, you go eliminate like one and then they both eliminate. If you get a contradiction, something that's not true, like 0 equals 2, that would be no solution. But since this is always true, there are infinite solutions. Now that doesn't mean any three random numbers for x, y, and z will satisfy all three equations. There are only certain subsets of all the possible values of x, y, and z that work. All right, so we can sort of think of these as like three planes intersecting in a line. So like that's kind of hard to draw, but if we had like one plane like this and like another plane like that, and then like a third plane, I don't know, it's hard to draw, but like this, like they all lie on this one line. So now we're coming up with all the points that lie on all three planes. So the way you do that is you go back to your equations with two variables. So like y minus 5z equals 0. And then you can isolate one of them. It doesn't matter which one. All right, so now for our ordered triple, like our final answer, all right, we're just going to let z be z. And then we know that y, so this represents x, y, and z, y is equal to 5z. Because that's what I know from this here. So to see what x equals in terms of z, we could take any of the original equations, which I'm just going to take the middle one because that seems to be the most simple one, just x plus y plus z equals 2. And then we could replace y with 5z, and z could stay, and then solve for x. So x plus 6z is equal to 2. X is equal to 2 minus 6z. And now that represents any ordered triple that would work, where z could be any real number. So this right here would be your final answer. And if you wanted to test a couple of points just to make sure that you did it right, like what you could do is like just choose a value for z, because z could be any real number. But if z is a specific number, like 0, then that means that, you know, if you plug in 0 for z, you get 2, 0, 0. Or if you get like, if you plug in 1, that would be -4, 5, 1. All right. Or if you get z is 2, you would get 2 minus 12, -10. 5 times 2 is 10, 2. So like if you plug any of these triples in together it would work on all three equations. All right. And there are an infinite amount that work, and they have to be in this form here.